I am Viswa ZPHS. Today we will discuss application of total internal reflection. How many applications are there total internal reflection? One is the coin disappear from view. Second, brilliance of a diamond. So third one, optical fiber, and the fourth one, mirages. We can discuss one by one. First of all, coin disappear from view. Place the coin, 5 piece coin on the table and keep the one transparent glass beaker over the 5 piece coin. After that, you have to see from the sidewise because of the light from coin falls on the glass wall and gets reflect, and this get refract, and we can see the image of this one. After pouring the water, this one, you have to pouring the water from this one. So we can't see the image from the sideways because of in this one. So this is the denser medium. This is the rarer medium outside. So outside is a rarer medium. So light is traveling from denser medium to rarer medium. So never be get refracted and gets reflect from this way. So that's why you can't see on sidewise from the sideways. See, we can see this one with experiment. Place the coin on the table. Keep a transparent glass beaker over a 5 piece coin. See this one, we can see the coin from this view sidewise. See this one, because of the light traveling from this medium, glass medium to air medium. In this one, light gets refraction. So that's why we can see the image by sidewise. If you pour the water, what will happen? See this one. Coin is disappear because of light is coming from this coin to here and gets a total internal reflection and go this way, this side, but will not come to this side. That's why the coin appear as a disappear. Second one is the brilliance of diamond. So brilliance of diamond, see the brilliance of diamond because of total internal reflection. So it has a critical angle is only 24 degrees 4 minutes, means when the light enters greater than this angle, it will take the internal reflection. See this one, when the light is incident on the diamond, what will happen here? Here it will take the refraction and dispersion. So this one we have to only here showing that violet and red only we are showing this one. This after that here this was a very low critical angle, so that's why it will take the total internal reflection. This one also total internal reflection. So and after that this one also here also gets the total internal reflection. This light will come this way. So that's why here so many times it will take the total internal reflection. That's why it diamond very appear as a shiny because of this one. Because of the total critical angle as a only 24.4 degrees. The main reason is the total internal reflection, mean TIR, total internal reflection. Third one is the optical fiber. So optical fiber is a fiber which is made of a thin fiber, very smallest thin fiber, having the radius. So this one micrometers. micrometer, very smallest radius. Micrometer means 10 power minus 6 meters. So very smallest radius. In this one, so light is which is made of a plastic or glass, which is made. So when the light is incident in this one, so it has a very small radius. So this one glances on the walls of this optical fiber. This optical fiber gets reflects from the space from the walls, and this one reflect like this way and travel in this way, and last one it will travel to the outside. So main this one optical fiber is it has a two contents are there. One is the core. This one is made of silica. In this above this one, cladding is there. Cladding is there. So here, so core is made of the more refractive index than that of cladding. Cladding. It has a core as a more refractive index. More refractive index than that of cladding. So cladding. So based on this one, so these optical fibers will be like follows this one. We can see this one. We can see this one optical fiber through a experiment. This is an optical fiber. If you send the light through this one, what will happen? See this one. See this one. Light is traveling in this way. See this one. Here get reflected. Here get reflects. Total internal reflection. Here also get total internal reflection. See this one. How is it possible? How is it light is traveling from one place? So in that is the curved path it will travel from. It will have a from the other end. Uses of optical fibers. Uses of optical fibers. In this way, see this one. In a medicine, and communication. In these two departments, we can use the optical fibers. In medicine, see this. All organs of human body not accessible to the naked eye of the doctor. For example, intestines, the doctor insert an optical fiber pipe into the stomach through the mouth. Light is sent down through the one set of fibers in the pipe. This illuminates the inside of the stomach. The light from the inside travels back through the another set of pipe, and the viewer gets the image at the outer end. This is outer end is connected to the computer. Important application of optical fiber is transmit the communication signals through the optical fiber, in which 2000 signals transmit the into pipe without interruption, which is much better than the ordinary conventional methods, that is ordinary through the satellites. This one may be tapped by the other enemies, so other foreigners. Mirages. Fourth one is the mirages. If we see that whenever we traveling on a road, so on a hot summer day, we can see this one. We appear as a collected water on the road, but if you get there, we don't find any water. This one is the mirages, optical illusion. This one is the optical illusion. So what is the meaning of exact definition? Mirage is an optical illusion where it appeared as collected of water on the road at a distant place, but if you go there, we don't find any water. So this is the called as a mirages. Mirages mean optical illusion. So we will explain this one. See this one. This is a consider this one. This is a road. This is the road. You have to consider this one. In this one, here see this one on during a hot summer day, just above the road as a very hot because of during the summer here this one is very hotted. So upper layer, the air at upper layer, that one is a very cool air. This one. So this is a hot air here. And so in this one, so whenever if you go to from ground to higher altitudes, the which one will be temperature decreases. Temperature decreases. If you go height, so temperature decreases. After that, so whenever the temperature here is more temperature here, so mean this gas will be go from this side to this side. So means what is the meaning of here this one density is called as a mass by value. So this gas will be go from this place to that upper place. That's why mass will be decreases. Automatically density also decreases. So density will be increases. So upward if you go height, temperature decreases, density increases. Automatically density is refractive index is directly proportional to density, so that's why refractive index also increases. In this one, see this one. This is considered as a you have to divide these layers, some layers. In this one, suppose here you have to consider the 1, 2, 3, 4, 5 layers you have to consider. This one has a low temperature. So this one is a low temperature. This one T1 you have to consider this one T1, T2, T3, T4. Here T1 is less than, T2 is less than, T3 is less than T4. But here refractive index for this one, first of all you have to take the density. Density for this one you have to consider D1, this one is a D2, D3, this is D4, this is considered as a D5. So here density is more, D1, D2, D1 greater than D2, D3 greater than D4, so greater than D5. You have to consider this one. Automatically, so refractive index is directly proportional to density. That's why. So you have to consider that this one is the refractive index N1, this one is N2, this is N3, this is N4, this is N5. So here mean N1 is greater than, N2 is greater than, N3 is greater than, N4 is greater than N5. So this means upper layer behave as a denser medium than that of lower medium. So compare these two medium, this one is a behave as a denser medium, this one is a rarer medium. So compare these two mediums. So this one behave as a denser medium, this one behave as a rarer medium. Compare these two, this one behave as a denser medium, this one is a rarer medium. Like this way, upper layer behave as a denser medium, lower medium is behave as a rarer medium. So whenever the light traveling from such as a tall object, so you have to consider that tall object. You have to consider the so even the sky also. So whenever see this one, light traveling from this medium to this medium, from the tree. So what will happen whenever, so this one come to this one, this is one denser medium, so this is a rarer medium. So comparing these two mediums, so in that time, so denser medium going to from denser medium to rarer medium, this is away from the normal. So after that, this one also takes away from the normal. So after some time it will get total internal reflection. Whenever this incident angle is greater than the critical angle, it will take curved path due to internal reflection. So appearing this one for this person is coming from the this due due to earth, from the earth. So this one is appear like from this side. So that person can see the objects, this reflected coming from the earth only. So that's why either maybe tree or sky, we can see the image of this inverted image or inverted image, virtual image we can see on the road. Mirage. Mirage is an optical illusion where it appears that water has collected on the road at a distant place, but we get there, we don't find any water. Mirage formation. First point, during a hot summer day, air just above the road surface is very hot and the air at higher altitudes is cool. Means temperature decreases with height. Second point, as a result, density of air increases with height and also increases refractive index with height because refractive index is directly proportional to density. Third point, the cooler air at the top has a greater refractive index than that of hotter air just above the road. Fourth point, light travels faster in hot air and light travels slow in cool air, means top surface air behave as a denser medium and low surface air behave as a rarer medium. Fifth point, when the light from a tall object such as a tree or from the sky passes through a medium just above the road whose refractive index decreases with ground, it suffers refraction and takes curved path because of total internal reflection. The sixth point, this is appears to the observer as if the ray reflected from the ground, hence we feel the illusion of water being present on the road, which is virtual image of the sky, inverted image of the tree on the road.